these problems, you guys don't have to recopy the whole problem. You could just list kind of the given information and what you're trying to find, because you don't have, if you want to, you can copy it. They're no more than like a couple sentences, 1 or 2, but a lot of information is in there. So I'm going to try and be kind of methodical about it, again, because I think it's a more difficult thing. So we're going to try to identify the given information every time and interpret which ratio is that. Like, is it length? Is it area? Is it volume? What's the ratio? And then we're going to see if we can find the other ratios from that and then answer the question. It's kind of the process we're going to use. So the first thing we want to determine is the given information. So when I read this problem, I have a couple pieces of given information. A square has an area of 25 units squared. And then they're increasing the area to 50 units squared. So the given information is about area, and it's going from 25 to 50. It's growing like that. Is that okay with everybody? I'm just picking out the given information. Because they're talking about two different sized things, something that went from being the size of 25 to a size of 50, that is something that we can set up in our ratio. Our ratios are always comparing this growth, or if something shrank, you could do that comparison. So we can write a ratio here that originally something was 25, and then we're comparing it to its new size of 50. And that's just like writing it in a fraction, like 25 over 50. And then we can reduce that. What can we reduce 25 to 50 to? What goes into 25 and 50? 25 or 5, okay? And then you can reduce it some more. And it ends up reducing down to 1 to 2, okay? Or 1/2, okay? So we've just determined a ratio. And what category did this ratio correspond with? A length comparison, an area comparison, or a volume comparison? Area, so it was specifically about area. So I'm going to make that little chart that we kind of talked about yesterday. I'm always just going to keep track of my ratios in this chart. So I'm going to have length. Sorry, my writing is really messy. Area, volume. And you guys just told me I've determined an area ratio. So I have something I can fill into that chart. And I'm going to ask you guys, and again, this makes it a little extra work, but we're going to try to fill in all the ratios before we go back and answer the question. Because sometimes the ratio is the answer. Sometimes the way they're asking the question, I have to use the ratio a different way to get the answer. That's a lot of steps. And so I just don't want us to get confused in what we're doing. So I'm going to try and figure out the other ratios. And in doing that, I want to remember what I know. So here's what I know. And these will not be given to you. These are technically not formulas. Okay? These are just a way to write this relationship that we studied. So you have to know this relationship. Okay? So what you know right now is this area relationship is 1 to 2. And that means that you know that the a squared is like a 1 when the b squared is like a 2. Does everybody understand why I didn't call 1 and 2 a and b? Why I called them a squared and b squared? Because they were an area ratio and not like a side length ratio. Is that okay? So I do want to know what a and b are, though, because if I look at my length ratio, like right here, I need to know a and b. So how can I figure out a and b with the information that I just wrote down? What would you guys do? You have that a squared is 1 when b squared is 2. How could you take that information and turn it into values for just a and just b without the squareds on them? Nami? Good. So we'll use a radical. Okay, we'll square root them. So if I square root them, a can be 1 when b is equal to, and you might not like this because we're not using a calculator. We're just going to leave it as rad 2, square root of 2. So now you've figured out, though, your a and your b, you've technically figured out another ratio. Your length comparison is not the same as the area. They don't double. They're not 1 to 2. They are 1 to the square root of 2, which is some decimal that's like 1 point something, something, something. Okay. All right, can I now figure out the volume ratio? How would I figure out the volume ratio? By cubing the numbers, right? So we have the a's and b's now, we just have to plug them in. So if a is 1, 1 cubed is still 1. If b is the square root of 2, we want the square root of 2 cubed. You can write it like the square root of 2 cubed, or you can remember that that technically means rad 2 times rad 2 times rad 2, which is the square root of 8. I don't care if you keep it this way, though. You can if you want, okay? You just have to be comfortable enough with your radicals to either leave it with a radical and an exponent or multiply out the radical, whatever you guys want. All right, so we have these ratios. They aren't all pretty, okay, but we have them and they make sense, and we're going to go from there. Now we want to identify, like, what are we actually trying to do in this problem? What was the question that they are asking us? And so here's their question. What factor would be multiplied by each side length in order to make this change, okay? So this question actually has two parts. First, what the heck does this mean? Factor being multiplied. And then it has like which measurement they actually want us to talk about in the answer. So they say by each side length. Which ratio does that correspond to? A length, area, or volume ratio? Length. They're talking about one specific side length, something I can measure with a tape measure. That means this is going to help me answer my question. Is that okay with everybody? So I take what's given to understand a ratio, and I can find all my other ratios. I need to read what they're asking to understand which one of these is about the answer, and then decide, do I just write down 1 to rad 2 or not, depending on what the question actually asks about the side lengths. So it says, what factor would be multiplied by each side? So do they want me to say 1 to rad 2? Does that answer someone's question like that? No, they want to know like, oh, times 3, times 6, times 8. Okay, but you can use this to answer it. We are going to use this. It's just not the final answer. Okay, so what this 1 to rad 2 means was the area went from 25 to 50. The sides went from 1 to rad 2. And the question is, what did 1 get multiplied by to change it into rad 2? And so you either know the answer to that question very quickly, or you write it as a math equation. 1 was multiplied by what to make it equal to rad 2? And then you would divide both sides by 1, and the answer would be rad 2. Okay? So the area might have been doubled, but the sides weren't doubled, right? Because they don't work the same. They're measured in different ways. The sides were only multiplied by rad 2, and that makes the area double. That's what that problem is saying. Is that okay with everybody? All right, so we're gonna do the next one. I'm gonna help you guys find the given information, and then I want you guys to try and fill in the ratio table and then answer their question. We'll see what people get and where you get stuck, so I can help you specifically with the issues you're having and not just like repeat the same process over and over again, okay? So the second problem says, what factor should be multiplied by each side length of a square in order to triple the area of the square? So the first thing we want to identify is what information is given here. So what's something where we know something about it? Okay, so, well, tripling doesn't necessarily mean cubing, right? It means like multiplying by 3, but that is a big deal here. We know that something is tripling. What is tripling? What about the square? Is each side length tripling? Is that what it says? Triple the area. So it's what is being multiplied by each side length in order for triple the area, right? So triple the area is what we know is happening. So we know that the area, we don't know exactly what numbers, so I'm just going to start with 1, is tripling, which means multiplied by 3, which means the ratio is something like 1 to 3. Even if you picked a number different than 1, you're like, how did you know it was 1? I don't know it was 1. Let's say you picked 5. When 5 gets tripled, it would turn into 15. But when you reduce the 5 to the 15, it would still reduce to 1 to 3. So when they don't give you the number and they say something like triple or quadruple, you could just start with 1, or you can start with anything, but it will reduce down to this, okay? So you guys have right now one of your ratios. We have an area ratio. So we know that the area ratio is 1 to 3. And so then go ahead and see if you can answer this question. But remember, think of it kind of in 2 steps. First, can I break it down and understand what all the ratios are? And then can I actually come back and answer this question, like what factor should each side be multiplied by? Okay, so if you don't know where to start with seeing if you can figure out the values that belong in the ratio chart. Okay, that's where you should start. All right, so you guys got this. What ratio were you able to find next after finding this one? Someone tell me. Length? Okay, and what did you get for length, Joe?
1 to the square root of 3.
Are you guys okay with how he got that? Okay, so again, the 1 and the 3 were kind of like our a squareds and b squareds because they were comparing area. So we wanted to undo that squaring and square root each of them to get back to our length ratios. And then what did that make the volume ratio? Somebody else give us the volume ratio. Thomas?
1 to the square root of 27.
Good. And technically the square root of 27 can be broken down, but in these problems, I don't care that much about that. I'm not looking for that, okay? I'm just looking for you to understand the relationships. Yeah, no?
They're going to be like the ratio is all 1.
There could be. And so that's where this next part comes in. So this one asks like what factor should each side length be multiplied by? So, sorry, I don't know why it's doing half the stuff it's doing. All right, so we're going to use length again because that's going to answer our question, but they didn't say what's the ratio. They said what is it multiplied by? So remember, you went from old to new. Like that's what happened to it. And so the question is 1 got multiplied by what to equal rad 3? And then the answer becomes just rad 3. If it wasn't 1, Noah, that's where like it's not as quickly intuitive. But if it was 6, it wouldn't matter if you write it this way. Like 6 times what gets turned into rad 3 divided by 6 then. Not any of that stuff. This is like my own little equation to interpret this. Like an old size got multiplied by something to turn into a new size. And my question is, what is that? And then I'm turning that into like a math statement. Like, so the old size of 1 got multiplied by some mystery number to turn it into a new size of rad 3. And then that mystery number would be rad 2. Is that okay? All right, we're going to do one more on here because it's a little different. It doesn't follow the exact same footprint. And then we're going to do one from your homework because it adds in like the beginning is the same, but it asks the question a little bit differently. And we want you guys to be able to interpret that. So we're going to go ahead and look at this third one will be the last one on here. And then one specifically, like I said, from the homework assignment. So let's talk about the given information in this one. So what is given in number 3 that's up here? Okay, so there's a volume of 8 units cubed and then 16. Okay, so we have volume. This is the general idea. It's going from 8 to 16. So they actually gave us the 2 different volumes, and that's where we can make the comparison in a ratio, right? A ratio can only come from if we have a beginning size and a new ending size, and we can compare them. So it's like 8 to 16. But you'll want to reduce numbers. They're easier to work with that way. And so this will reduce to 1 to 2. Okay? So we just figured out a ratio, a comparison of a smaller one to a bigger one, specifically in the realm of volume. Okay? So see if that helps you, and if you can go through and answer the rest of this question, we'll go through it, and then we'll do one from it. All right, so what ratio did we have right at the beginning? 1 to 2, which represented what type of measurements? Volume. And remember, volume is our cubed versions of our A's and B's. So if I want to undo this, remember this is that A cubed is like a 1 when B cubed is like a 2. If I want to know what A and B are without the cubing, I would have to cube root them, giving me that A is like 1 when B is like the cube root of 2. Okay? Those A's and B's by themselves relate back to length. All right, so one of the main things I saw when I was walking around and looking at your guys' work is that you really like patterns, and because the first 2 said area and you just square rooted them and wrote them in the other thing, like that's exactly what people wanted to do again. And so I would really advise that we keep track of these thoughts next to them. So we don't just fall into like automatically doing one thing or another, but recognizing which one's the cube, which one's the square. And so that here, when I get A and B, I know that that doesn't get written in the area one because the area has to have A squared and B squared. Does that make sense to everybody? So these things are helping me organize them. A lot of you guys don't have that on your paper. I'm okay with that if you're still able to comprehend it. But if not having that is causing you to make a quick error, then I think that we should have it, okay? And then if I want to know the area ratios, those are A squared and B squared. I'm now going to take the A value that I got, which was 1, and square it, which is still 1. And the B value that I got, which was cube root of 2, and square that. Remember that cube root of 2 squared means cube root of 2 times the cube root of 2, which we could then write as the cube root of 4. It's okay if you kept it as the cube root of 2 squared. I'm not going to be picky about that. It's just what you're comfortable with to be able to use it later. Okay? Is everybody okay with where all of these ratios came from based on the given information? Okay. And then what are we answering a question about? Are we answering a question about a specific length, an area calculation, or a volume calculation? What factor would be multiplied by each side length? Is that something we can measure with a tape measure? Yes, so it falls just into this basic length category. Okay. So this ratio is going to help us get our answer, but they didn't say what is the ratio, so I can't just like write the ratio down as the answer. I have to answer their question, which was, when this change was made, what are things getting multiplied by? So in other words, they're changing from something like a 1 to something like a cube root of 2, and their question is, 1 times what is turning into cube root of 2 then? Okay? And the answer to that is just cube root of 2. Okay? And if it wasn't a 1, it would say, 3 times x equals cube root of 2. And then we would just solve it that way. It's all right with everybody, generally. At least you could give them a shot. Do we have enough organization to like have a strategy to start a problem that asks us this one line that's extremely complicated? Okay. And then we're going to do one problem from your homework. So the next thing we're going to do is part of homework number 2. Okay. So you can do it on there and then just copy it over later, or you could take out a sheet of paper. You're going to label homework number 2, and you could just go out of order and do this one first, whatever works for you. There are 7 problems in this homework assignment. We are going to look specifically at number 6. Okay. Right, and we're going to use the same strategy, like the same kind of order that we did before. And again, if you have a different way, 100% on board. But the reason I'm sticking with the same strategy is so that when people tell me that they don't know where to even start, we can give them a starting strategy by looking for the given information and filling in ratios and then coming back to the question. All right, so what is given here?
Diameter.
No diameter. Oh, we're looking at 6.
Oh,
That's okay. Okay, so there's this given about a volume of 320 meters cubed. All right, what else is given to us? What else do we know? The dimensions are changed to 1/4 of their original size. Okay. Can we write a ratio with the 320 from the volume measurement? They gave us a volume measurement, but we can't use it in a ratio because did they give us the new and improved volume measurement? No. So we have the 320, but we don't have anything to compare it to. So we want to keep it as part of our given information, but do you recognize why I'm not using that to write a ratio right now? I don't have a comparison, a before and after for volume. The other sentence that is given says the dimensions are changed to 1/4 their original size. Okay, dimensions is talking about what type of measurement? A length, an area, or a volume? What are dimensions? Length. The dimensions are like the different, like a length, a width, a height. Those are dimensions. So if you buy a package, it'll say on the package dimensions, and then it will give you the dimensions for the package as well as the dimensions for the built object. And when they say that, they're referring to the different measurements either in the package or when it's built. Okay? So dimensions are individual length measurements. so this is talking about lengths, are changed to 1/4 their original size. So that's actually a ratio right there. I don't know the exact numbers, but I know it started at something, so I'm just going to call it a 1 to start with. And then it changed into 1/4 its original size. So this is not actually growing, it is actually shrinking, right? Is that okay? How many people aren't giant fans of the fractions in here? How many people don't really want to use the fraction? People? All right. We can get rid of it if you want. Any ideas how we can not have a fraction anymore? We can multiply by the reciprocal of it, okay, by 4. And we can do that because as long as we do it to one side, we can do it to the other side. That works in a ratio because a ratio is like a fraction, and you can multiply the top of a fraction by 2 as long as you also multiply the bottom by 2. And so then this will become 4-1. Do you guys like those numbers better?
Yes.
Okay, so first purpose of doing this problem, if you come across a problem with a fraction and you don't like the fraction, you can adjust your ratio. So use that skill when you feel necessary, okay? The next thing is putting together our chart now that we have a ratio. And which ratio did we say this 4-1 belongs to? Which kind of measurement? Length, good. Right, so I'm going to use that, and this is actually much nicer than the other ones we did. If this problem's simpler in any area than the ones that you did previously, it's this. By giving you the 4-1, because that's an actual length ratio, they are straight out just giving you the A's and B's. You don't have to square root anything or cube root anything. You have the most simple version of it. No. So the given volume was 320, but then this sentence says the dimensions are changed to 1/4 their original size. So that volume's like an extra piece of given information right now, and then we'll see if we have to use it to answer the question or not. But does it make sense why I don't have a volume ratio? I would have a volume ratio if they gave me the 320 and then they gave me another volume to compare it to, but they didn't. Okay. Very good question. All right, so then this is what's in my head, right? That I know these relationships between these different comparisons. And so I basically right now know that A can be 4 when B is 1. And so I can square those things to get the area ratio. So 4 squared would be 16 and 1 squared would be 1. And I can cube the 4 and the 1 to get the volume ratio. So 4 cubed is 64 and 1 cubed is 1. Is everybody okay with how I filled in the ratios? I didn't take as much time this time because they gave us the simplest one, but if you don't understand, it's my job to explain it to you. So if you don't understand where any of those things came from, let me know. Okay. All right, so now let's figure out what we have to answer, okay? So what is the question in this problem? So what will the volume of the new cube? So out of these ratios, which one's going to help me? 64-1, because that's the volume comparison. Did they ask for the ratio? Did they say what's the ratio of the volumes? No, so I don't just get to write 64-1. Did they ask what they were asking us before, like what did I have to multiply by to get? No, okay? So it's a little bit different. They are asking what is the new volume, okay? So here's what I know. In this, all of these are the old measurements compared to the new measurements in my ratios. So you kind of have two ways to figure this out. One way is if you immediately see a relationship between multiplication or division to get from the old one to the new one, you can just apply that mathematics to the 320 number and figure it out. Okay, so does anybody see what I'm talking about? Does anybody look at this and go, oh, I know exactly how you change 64 into 1? And it has to either be divide or multiply. We don't add or subtract when we're doing proportions. Divide by 64. So one way to solve this problem is to take any old measurement, if it's talking about volume, you divide it by 64 and it turns into the new one. Is that okay with everybody? That's one way. Okay. If that doesn't make sense to you, there's another way to solve this. Okay. What do we often use with ratios? We usually learn ratios and they compare things, but then when we start solving with ratios, there's another word that usually goes with it that describes what we do. Fractions are ratios. Do you know what we call it when we set two of them equal to each other? a proportion, okay? And proportions just say you're comparing the same things. You know they're supposed to work out the same, but you don't exactly see the math yet of how to do it. So what we would say here is I know that when I compare old measurements to new measurements, it's supposed to work out to be 64-1, right? That's old compared to new. But right now they gave me a number that's not 64, it's 320, and I'm supposed to understand how that turns into the new measurement. But it's supposed to work just like 64-1 because it's the volume from the same problem. Is that okay with everybody? So I know that 320 is supposed to turn into something new exactly the way that 64 turned into 1, and that's why I'm allowed to set them equal to each other. And then you can just cross multiply it to solve it. Okay, so 64 times x is 64x, and 1 times 320 is 320. And then we would divide by 64, and that's how you'd get your answer. Notice that your final answer is coming from taking 320 and dividing by 64, just like what was pointed out to us right here, that they saw like, oh, I could just divide by 64, and that's why that works as well. Okay, and so you would then get whatever 320 divided by 64 is, that gives you your new volume. Okay, is that all right with everybody? So the questions can be the trickiest part of this. I mean, this was two sentences technically, but this is a super complicated math question, right? In 2 sentences. So please don't read it and think that just because it's 2 sentences, you should be able to simply spit out the answer, process the given, understand your ratios, decide which one's going to help you solve it, and then solve it. Okay? If you see faster patterns and you're able to get them right, you can definitely go faster than what I'm doing. Okay? All right.